Hello, welcome back. So today in this episode, we are going to look at implementing some hashing. So as a quick recap from the last episode, we whoops, whoa, no, not that. So as a quick recap from the last episode, we implemented a recursive function to iterate through all the directories for a given file path. So what we want to do is we want to hash all of the files in that directory. Why do we want to do that? Well, we want to do that so that we know that the files that we're dealing with are unique. Into this example that I've used. So here we've got two files. They're the same file, they're the exact same image, but we have them in two different locations. So we need to hash these so that the hash for this file and the hash for this file are going to be the same, and then we know these are the same files. So when we back it up, we only back it up once, or we can sort through and see all the times where we have duplicates. So how are we going to do that? We're going to have to use a hashing algorithm. SHA-256 is a popular algorithm that we can use. So this wiki page is going to be super detailed, and we can go into really deep as to how it works. But that might be the topic for another video. I think we kind of don't need to know the in-depth details of how it works. This is a beginner series after all, so let's just implement it, and then maybe later on we can go back into the detail a little bit more. But if you're interested, obviously do your own research and come in here and see how it works. But what we want to know is Golang SHA-256. How do we implement it in Golang? So Go has this crypto package, and we can use that to create a hash. Okay, here we go. Cool. So yeah, this is the example that we can follow. So we can create a new hash based on the bytes that we pass into it. Okay, so in this example here, this is kind of the hello world of hashing here. So what's happening is we're importing the crypto SHA-256 package module, and of course the format one as well, so we can print it out. And then what we're doing is we're creating a new variable here for this SHA-256 new function. And then from that, we call the write function and pass in the bytes of this hello world string. And then here we can see it hashed out. So we want to do the same, except instead of passing in a hello world string, we want to pass in the bytes of an image. So for each of the image files that we have, we'll end up creating a hash that looks something like this. And then each of those image files should have a unique hash. If they're not unique, then it means they're the same image. So let's take a look at implementing that. Okay, so to implement it, the first thing that we want to do is we want to get the bytes of the file. So what we need to do is open the file. So in this recursive function where we left off last time, we've got this check to see is it a directory. So if it's a directory, then we call the recursive function again, and we keep on going. So in a way, we want to change this to not list them out, but we want to hash them. So let's change this to hash dir files recursive. Okay, so let's just update the comment a little bit too. Um, so iterate over entries in a directory path, hash all of the files that we find there. Okay, we can make this look nicer later, but let's just go with it. So here. So here, check if it's a directory. If it's a directory, we go one layer further. But otherwise, we want to deal with this file. So right now, we're just printing out the name of it. But what we probably want to do is open up that file. So open the file. Open meaning read the file. So that means we can grab the bytes of that file, chuck it into a variable, or we can at least use it. If we open this file for reading, then that'll give us the ability to use it for hashing. So we need to open the file, and then we need to hash the contents of the file. And then for now, let's just print out the hash. Just we'll do all kinds of comparison later and all kinds of deduplication later. But first, let's just print them all out, and then we'll be able to see in the list where they are the same. So we need to, and I think we touched on this before, we need to make use of the open OS open function. So, okay, so here, this is how we open a file for read access. So simply OS open. So the file's data can then be read into a slice of bytes. Read and write take their byte counts from the length of the argument slice. Okay, yeah, so we can grab the data. I think there is a better way to do this though. So let's start off by using this. So we'll start off by opening the file, and then we'll go from there. So os.open. So I think we're already using the, okay, no, we're not using the term file yet. So let's use that. So file, file or error, and OS open. So we'll assign that to OS, and then we'll use the open package. Whoops, that should be a capital O. And then we'll pass in the this full file path. Let's save this here in a variable. So file path will be, oh, okay, sorry, we're already using that. Oh, actually, no, sorry. Yeah, so file path is this package here. So let's just call it full path. And then we'll give it file path join the directory path and the entry name. Full file path. So here we can open the full file path. and we need to handle the errors. So if error is not nil, then we're going to want to log fatal error. Okay, so now in file, we've got the file opened, and we can yeah, we can handle that. So I think what we can also do, and what we should do in Go is close the file afterwards. So we can use this defer command, and then close the file. So again, we'll probably go into this more later, explain how this works, but for now, it's kind of how it sounds, right? So we're saying close the file, but defer doing that until later. So this just allows us to say that we want to close the file when we're not using it anymore, and yeah, we'll look more into that later. So now we've got the file open. What we want to do is we want to get the bytes into our hashing function. But let's bring that in first. So we're going to be using the crypto SHA-256. Oops. The crypto SHA-256 package. And with that, we'll get we'll make use of that new function here. So here we're essentially going to do this. So let's do the same thing. Let's give it a little bit more description than just H. Let's call it hasher. And here we'll do the same thing. So SHA-256 new. Okay. So now we've got a hasher, and we need to use it. So we need to pass in the bytes and write to it here. So can we just pass in the file directly? I'm not too sure. I don't think we can. I think we need to get the bytes from it first. But let's try it. Let's try it and see if it works or not. So we need this write command here. So hasher write, and let's just pass in the file and see what happens. So okay, let's take a look at this write function first, though, because because then we can get an idea of how to use it. Where is it though? I don't see it in here. Okay, go SHA-256 write. Okay. All right. So okay, so here we have an example with a file. I mean, this is exactly what we want to do. In fact, yeah, it's even using the defer function and everything. So it looks like this is, yeah, this is more in line with what we want to do here. So here, what is the difference? So instead of using the write function, we just copy it over. So IO copy, okay. So let's go to the IO. IO copy. Here we go. Right. So copy copies from source to destination until either end of file is reached on source or an error occurs. It returns the number of bytes copied and the first error encountered while copying, if any. A successful copy returns errors nil. Okay, cool. So it looks like we can use this to extract out the bytes from the file. And here's an example where we're copying it straight to the hasher, the SHA-256 hasher. Great, and there's error handling there as well. Okay, so this looks much better than what we're trying to do here. So let's get rid of that write function. And instead, we'll chuck this in an if statement. So if here we have nothing and then error. Okay, so this is, yeah, right. So this is setting the condition. And we're going to use the IO. So we're going to have to import IO. So let's import that as well. Right, and then what we want to do is use the IO copy, and then we copy to the hasher from the file. So hasher file. Yep, and then if there's yeah, okay, so the final condition is if error is nil. So error, sorry, if error is not nil. So if error is not nil, then we log this fatal error. Log fatal error. Okay. Great. So we've got the hasher created and we're copying in the file to it. And then it looks like the final stage is using the sum function. So let's go back and take a look at the sum function. Okay, so this is doing it all in one here. So I wonder if things has changed because this documentation is totally different to the other documentation here. Is this a previous version or something? Yeah, so this is Go version 1.8.5. So maybe things have changed. Maybe this isn't the best practice anymore. Let's try it out and see how it goes, and then maybe we'll need to come back and do it this way. Yeah, but let's try it first. So here we just print out so yeah, in this case when we're printing out the hash, we can okay, yeah. So this here is the binary representation. So Golang formatting %x. So where is x? Okay. Yeah, so this is the base 16 sorry, not binary. This is the hexadecimal, the base 16 lowercase letters for A to F. Okay, so that's the representation that we'll have. So we'll represent it as hex here, and then we'll pass in the sum of that hash. So going back to the example, we use hasher sum and then nil. So hasher sum nil. It would be good to get the definition on this sum function so we can see what is actually getting passed in there. But let's run it for now. And we can first of all make sure that it compiles. It does not. Okay, so line 41, unexpected new line in arguments list, possibly missing comma. So image sorter line 41. Okay, yeah, so we just didn't close that off properly, missing that final parentheses there. Let's try building again. Okay, undefined. Right, yeah, we changed the name of that. So let's go back and fix that up. So line 23, what do we call it? Hash. So now it's hash directory files recursive. And then where was the other one? This one, hash directory files recursive. Okay. Try build again. Okay, spelled that wrong. Hash. Okay, that's second one there. That should be lowercase. Okay. Cool. Okay, so it all compiles now. Let's run it, but let's run it on a smaller subset. So let's run it on this unsorted directory here. So here we're gonna give it C users recording dev image sorter photos, and let's just do it with the unsorted directory. Oh, whoops. Okay, sorry. That's Explorer. That's not our application. We want image sorter. That's us. Okay, great. So here we go. So now we've got the hex being printed out of the hash, and it looks like these are exactly the same. So this is exactly what we want here. In here, we've got these two files. They're exactly the same file, even though they're named differently. This one's called photo, and this one's called best life. But they are exactly the same photo, and we can see that the hash matches. So every single number here is the same. And this is how we're going to work out that even though they're named differently, they're the same file, and we only want to back it up once. So this is the essence of our deduplication. Now it's printing kind of weird. I don't know what's going on there. Why do we have %x and then that? So let's see, what are we printing out here? Yeah, okay. I mean, let's just try getting rid of all of that. Can we just print out the thing directly? No. Oh, whoops. Sorry. Got to build it. Okay, we can. Yeah. So here we can see these are exactly the same, which is really cool. So I mean, let's do it with more. Let's do it with everything in there. And here we're going to grab, yeah, all of them. So we should have another instance where this is the same because I think it's in, yep. So, whoops, no, where are we? 236. Yeah, so this one here. So this is the other one that's exactly the same as those two. So we have 3 copies of the same file. So the next step after this is we need to actually store these. We could store them in memory and iterate through, but it might be a little bit better if we store this in a database. And then we can store, first of all, the hash as the key, and then every file that goes with it. Every time we've seen that hash, we record the file location. So we can start building up a database of these are all the files we have and where we've seen them in different places. Cool. So let's do that in the next video. I think we have a good implementation now of the hash. There are some things that we kind of skipped over, and I think it would be good to go back and understand how these things work. So this sum function, it looks like it is used, even though it's not in the new documentation here. So yeah, this sum 256. I mean, we could try and use this instead. Um, so yeah, we could try and do that instead, but I think maybe I'll dig through and oh, okay, wait a minute. There's an example here. So this is the latest documentation, and this looks like it's the exact same example that we saw in the other documentation. Yeah, it's doing it exactly the same way that we're doing it. So okay, it looks like we are doing it the best way. With the latest version. So okay, so that's cool. So it looks like here you create a hasher with this SHA-256 algorithm, create a new one. We're using this IO copy function to pass in the bytes from the file to this hasher new. If there are errors there, then we log them out. Otherwise, we go forward and print out the sum with nil there. So this is the part that I'm not entirely sure about. There's no real documentation on this part. So I mean, we can probably take a bit of a guess as to what it's doing. Okay, is this for the checksum? Okay, right, okay. So yeah, in this case, let's just keep it simple. We just want to create a hash and keep a record of those so that we can see if 2 files are the same. We don't need to really go in depth on that. So I think maybe in another video we'll go through hashing in a bit more detail. We'll look at the more technical side of things. But right now, just as a basic implementation, we have it working, right? We want to know if one file is the same as another file, and we've done that. So I think we're at the point where we understand how all this code is working. It's doing exactly what we want it to do. And then perhaps later we can go through and look at the more technical details of SHA-256. If you're interested, do a bit of research by yourself. Maybe we'll come back at the end of the series and look at that in more detail. But for now, we have our hashes. This is all working. And then maybe in the next stage, we'll look at storing that somewhere so that we can go back later and compare all of these files.